What is a security architect? Security architects are responsible for designing, building, and maintaining the security functions of an organization's IT environment. Security architects help translate an organization's business and assurance goals into a security vision, providing documentation and diagrams to guide technical security decisions. They're responsible for ensuring that the information security requirements necessary to protect the organization's core missions and business processes are adequately addressed in all aspects of enterprise architecture. This includes reference models, segment and solution architectures, and the resulting information systems supporting those missions and business processes. Best practices are recommended ways to do things that have been found to be most effective or efficient. Best practices help you avoid mistakes and ensure that your resources and effort aren't wasted. Exact instructions on what to do, why to do it, who should do it, and how to do it. High-level principles to help with different types of decisions and actions. Guidelines that are part of a reference architecture that describes components that should be included in a solution and how to integrate them. An anti-pattern is a common mistake that leads to negative outcomes. It is the opposite of a best practice. Many best practices are designed to help you avoid anti-patterns. Best practices are recommended ways to do things that have been found to be most effective or efficient. Best practices help you avoid mistakes and ensure that your resources and effort aren't wasted. Develop and implement an end-to-end technical security strategy focused on durable capabilities and zero-trust principles. This workshop helps you define and rapidly improve on best practices across security, including asset-centric security aligned to business priorities and technical estate, beyond network perimeter, consistent principle-driven approach throughout security lifecycle. Pragmatic prioritization based on attacker motivations, behavior, and return on investment. Balance investments between innovation and rigorous application of security maintenance, hygiene. Configure before customize, approach that embraces automation, innovation, and continuous improvement. Security is a team sport across security, technology, and business teams. Anti-patterns. An anti-pattern is a common mistake that leads to negative outcomes. It's the opposite of a best practice. Many best practices are designed to help you avoid anti-patterns. An example of a best practice that helps you overcome numerous anti-patterns is applying security patches regularly. Microsoft has observed multiple anti-patterns that get in the way of regularly applying this basic and critically important security best practice. Skipping basic maintenance, skipping backups, disaster recovery exercises, and software updates, patching on assets. We don't patch unless it's critical. This anti-pattern avoids patch installation because of an implicit assumption that patches aren't important. Another version of this is that it won't happen to us, a belief that unpatched vulnerabilities won't be exploited because it hasn't happened before or hasn't been detected. Waiting for patch perfection instead of building resilience. This anti-pattern avoids patching because of a fear that something could go wrong with the patches. This anti-pattern also increases likelihood of downtime from attackers. Broken accountability model. This anti-pattern holds security accountable for the negative outcomes of patches. This accountability model leads to other teams to prioritize security maintenance over customizing patch selection. This anti-pattern uses unique criteria for patching instead of applying all manufacturer-recommended patches. This customization effectively creates custom builds of Windows, Linux, and applications which have never been tested in that exact configuration. Focusing only on operating systems, this anti-pattern patches only servers and workstations without also addressing containers, applications, firmware, and IoT/OT devices. Securing cloud like on-premises, attempting to force on-prem controls and practices directly onto cloud resources. Wasting resources on legacy system maintenance and costs, draining ability to effectively secure business assets. Disconnected security approach, independent security teams, strategies, tech, and processes for network, identity, devices, etc. Lack of commitment to lifecycle, treating security controls and processes as points in time instead of an ongoing lifecycle. Incorporating risk into cybersecurity strategy. In the evolving landscape of cybersecurity threats, defining a robust strategy requires more than deploying technical controls. It necessitates a risk-aware approach that integrates business objectives with security priorities. A comprehensive risk framework provides the structure to identify, assess, and manage these risks effectively, aligning cybersecurity measures with the organization's broader goals. At the core of this approach is the need to understand an organization's risk posture, its tolerance for potential impacts balanced against its operational needs. This understanding helps prioritize security initiatives, ensuring that resources are focused on mitigating the most critical threats. This slide is used to highlight how to think about risk. That said, it is also important to highlight that risk considerations and risk management must be seamlessly integrated into every aspect of an organization's technology architecture. Throughout this module, you'll explore different security frameworks: Zero Trust, CAF, WAF, MCSB, MCRA. Risk management must be seamlessly integrated into every aspect of an organization's technology architecture. Each framework that we'll explore, Microsoft's Zero Trust Framework, Azure Cloud Adoption Framework, and Azure Well-Architected Framework, provide distinct but interconnected approaches to embedding risk considerations into security, cloud adoption, and architectural practices. Zero Trust Framework Overview: Zero Trust operates under the principle of never trust, always verify. Every user, device, and access request is treated as potentially compromised until verified. This approach prioritizes minimizing risks associated with lateral movement, privilege escalation, and unauthorized access. Risk integration, identity and access management. Risk-based conditional access policies assess signals such as user behavior, location, and device compliance before granting access. Tools like Azure AD Conditional Access enforce these policies dynamically. Least privileged access. Privileged access is tightly controlled, reducing the attack surface for critical assets. Microsoft tools like Privileged Identity Management, PIM, enable temporary, just-in-time access. Assume breach. By designing systems with the expectation of compromise, Zero Trust integrates monitoring and detection tools like Microsoft Sentinel and Microsoft Defender for Identity to detect and respond to anomalies in real time. Azure Cloud Adoption Framework Overview: The Azure Cloud Adoption Framework provides a structured approach to planning and implementing cloud adoption initiatives. Risk considerations are embedded across its phases, ensuring that security and governance are integral to the cloud journey. Risk integration, strategy and planning. During initial phases, organizations assess business risks associated with cloud migration, including data sovereignty, compliance, and operational impact. Governance and compliance. The governance benchmark within the framework ensures alignment with regulatory requirements, using tools like Azure Policy and Compliance Manager. Operational management. Ongoing risk management is achieved through monitoring tools like Azure Monitor and Log Analytics, which provide insights into performance and potential vulnerabilities. Secure design. Security baselines and architectural decisions mitigate risks during implementation, supported by resources like the Azure Security Benchmark. Azure Well-Architected Framework Overview: The Azure Well-Architected Framework provides best practices for designing cloud solutions that align with 5 pillars: reliability, security, cost optimization, operational excellence, and performance efficiency. Risk integration. Security pillar identifies risks tied to identity, infrastructure, and data security, offering mitigations such as encryption, network segmentation, and access controls. Tools like Azure Key Vault secure sensitive data. Reliability pillar proactively addresses risks that could impact availability, such as disaster recovery, system failures, or capacity issues. Azure Site Recovery and Azure Backup ensure continuity. Operational excellence pillar promotes monitoring and alerting practices to identify risks and anomalies, leveraging tools like Azure Monitor and Application Insights. Risk review. Regular architectural reviews identify and mitigate risks in cloud deployments, with tools like the Azure Well-Architected Review offering actionable recommendations.